Hello everyone, I am Dr. Sirajul Faisi. I welcome you in my YouTube channel. Today in this video, I am going to talk about stoichiometry. You know my friend, calculation with chemical formulas and equations I will discuss in this video. So anatomy of chemical equations. You can see here CH4 plus carbon dioxide, oxygen, it gives carbon dioxide and 2 molecules. So you can write this way: 2 molecules oxygens, carbon dioxide, 2 molecules water. So 1 carbon, 4 hydrogens, here 4 oxygen, here 1 carbon, 2 oxygen, here 2 oxygen, 4 hydrogen. This is the reactant appear on the left side of the equation, and this is the product. So the state of the reactant and product are written in the parenthesis to the right of the each compound. You see G means gas. Now coefficient are inserted to balance chemical equation. This is the coefficient, this is the coefficient. So subscripts and coefficients give different informations. You can see these are the chemical symbol. This is the meaning: 1 molecule of water, 2 molecules of water, 1 molecules of hydrogen peroxide. Here compositions: 2 hydrogen atom and 1 oxygen atom, 4 hydrogen atom and 2 oxygen atom, 2 hydrogen atom and 2 oxygen. So subscripts tell the number of atoms of each element in a molecule. So subscript tell the number of atoms of each element in molecules, and coefficient tell the number of molecules or compounds. This statement is very important. Coefficient tells the number of molecules and subscript tell the number of atoms. Now types of reaction. Combustion reactions. You can see this magnesium. This is oxygen. It gives magnesium oxide. 2 or more substances react to form one product. Same way, nitrogen 3H2, propane and bromine, magnesium react with oxygen forming magnesium oxide. So this is the reactions. Now decomposition reaction. One substance break down into 2 or more substances. You can see calcium carbonate. Combustion reaction. You can see rapid reaction that have oxygen as a reactant, sometimes product, a flame. So this methane react with carbon dioxide and 2 molecules water. Now formula and weight. Define 1/12 mass of the carbon-12 isotope, that is 12 AMU. So formula weight, FW, sum of the atomic weight of the atoms in a chemical formula. So the formula weight of calcium chloride is like this. So these are generally reported for ionic compounds. Now molecular weight, sum of atomic weight of the atom in a molecule. For the molecule ethene, C2H6, the molecular weight would be like this. Now percent composition. One can find the percentage of mass of a compound that comes from each of the elements in a compound by using this equation. So percentage element is the number of atoms multiplied by atomic weight divided by formula weight of a compound multiplied by 100. So percentage of carbon, percentage of hydrogen is 80% and 20%. Now mole, atomic mass unit and the moles. AMU definition, carbon-12 is equal to 12 AMU. The total mass unit is defined this way: 1 AMU is equal to this gram. And how many carbon-12 atom weight? 12 gram. So this is the weight of 12 gram. You've got a name and mole. So atomic mass unit and the moles, AMU definitions. Here, Avogadro is equal to 1. Now, any single molecules, 1 molecule H2O, and laboratory size example, 1 mole of H2O. Avogadro's number of molecules is this. So 1 mole H2. So 1 molecule, 1 mole H2 gram. So 1 mole of carbon 12 has a mass 12 gram. Now, the mole is just a number of things. 1 dozen, 12 things. 1 pair, 12 things. 1 mole is equal to these things. So molar mass, the trick. By definition, this is the mass of 1 mole of substance, gram per mole. Molar mass of an element is the mass number for the elements that we find on the periodic table. The formula weight in AMU will be the same number as the molar mass in gram per mole. Now using mole, gram, use molar mass to mole and use Avogadro number formula units. So mole provide a bridge from the molecular scale to the real world scale. The number of moles correspond to the number of molecules, and 1 mole of any substance has the same number of molecules. Now mole relationship. You can see atomic number nitrogens, formula weight, and this way. So 1 mole of atom, ion or molecules contain Avogadro number of those particles. 1 moles of molecules or formula unit contains Avogadro number times the number of atoms or ions in each element in the compound. Now finding empirical formula. So combustion analysis gives percentage composition. You have the sample here. You have O2, furnace, copper oxide, water absorber, CO2 absorber. This is the way to set up. First yellow, then here blue, then green. This is the furnace, O2 and CO2 half. So compound containing carbon, hydrogen, oxygen are routinely analyzed through combustions in a chamber like this. So one can calculate the empirical formula from the percentage compositions. Now calculating empirical formula. The compound para-aminobenzoic acid you may have seen is listed as PAB on your bottle of sunscreen. Is composed of carbon 61.31%, hydrogen 5.14%, nitrogen 10.20%, and oxygen 23.33%. Find the empirical formula of PAB. So you can calculate like this. Calculate like this, 772, this is the one. Then this is the formula. These are the substance for the empirical formula. C7H7NO2. Now, elementary analysis. Compound containing other elements are analyzed using method analogous to those used for carbon and hydrogen and oxygen. So, stoichiometry calculation, 2H2 plus O2, 2H2, and molecules, 2 molecules H2, 1 molecule O2, 2 molecules H2, mass 4 AMU H2, 32 AMU O2, 36 AMU water, amounts 2 moles H2, 1 mole O2, 2 moles water. So the coefficient in the balance equation gives the ratio of moles of the reactant and products. Very important point. Now stoichiometry calculations. From the mass of substance A, you can use the ratio of the coefficient of A and B to calculate the mass of substance B. Form it is a product, or use if it is reactant. So given gram of substance, use molar mass of A, molar mass substance A. Use coefficient of A and B from balance equation, moles of substance B. Use the molar mass of B, gram substance. Now stoichiometric calculations, how you will perform. Example, 10 gram of glucose react in a combustion reaction. How many grams of each products are obtained? So starting 10 gram, we calculate the moles, use the coefficient to find the moles of H2 and C, and then turn the moles to gram. Like this. So now limiting reagents. How many cookies can I make with the butter, sugar, flour, egg? So you can make cookies until you run out of one of the ingredients. Once you can run out of sugar, you will stop making cookies. So in this example, the sugar would be the limiting reactant because it will limit the amount of cookies you can make. So what is limiting reactant? The limiting reactant is the reactant present in the smallest stoichiometry amounts. That is the limiting. In the examples below, the O2 would be the excessive reagents. Now limiting reagent, for example, soda fish comes from sodium bicarbonate and citric acid, reacting to make carbon dioxide, sodium citrate and water. If 1 gram of sodium bicarbonate and 1 gram citric acid are reacted, which is limiting and how much carbon dioxide is produced? So this is if citrate limits, you do the calculation like this. Then bicarbonates. You know the theoretical yield. Theoretical yield is the amount of product that can be made. In other words, it is the amounts of the product possible from stoichiometry, the perfect reactions. This is the difference from the actual yield, the amounts one actually produces and the measures. So first you calculate the theoretical yield, then percentage yield. A comparison of the amount actually obtained to the amounts it was possible to make. So actual yield divided by theoretical yield multiplied by 100 is equal to percentage yield. So this is the examples. If you have the benzene react with bromine to produce bromobenzenes and hydrobromic acid. If 30 gram of benzene react with 65 gram of bromine and produce 56.7 gram of bromobenzene, what is the percentage yield of the reaction? So this is the calculations. Another example. Now gunpowder reactions. If you have saltpeter, sulfur and charcoal, this product. So it is interesting about this equation. What kind of reaction is it? And why do you think make it is so powerful? So this is oxidizing agent, oxidizing reducing agents. What is interesting about this reaction? Lots of energy, no oxygen. What kind of reaction is it? Oxidation reductions. What do you think makes it so powerful and explosive? Makes a lot of gas. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel and thanks for watching.